Hello physics students. In this video I'm going to present the answers to this little experiment that I did in my basement, the electrostatic charge experiment. So let's move on to the pith balls number 1. Okay, so remember there I charged a plastic rod by rubbing it with fur, and then the rod exhibited charge effects. So what I asked you to do is draw a charge distribution of the rod and the fur before the rubbing. And so notice I drew a plus minus here, a plus minus here, a plus minus here. This represents 3 atoms because remember everything is made of charge, including this paper, this pencil by hand, but everything usually is neutral because it contains the same number of protons as electrons in that state. So that's why it has just as many positive coulombs as negative coulombs, so it has a charge of 0. And the same thing is true of the fur. I've got 4 atoms, simple atoms drawn here and 3 here. So of course there are different number of atoms in different objects. After I rub them together, what happens is, notice the rod has the same atoms as before, but now it's picked up a couple electrons. It picked those up from the fur, so now there are 2 atoms here that are missing an electron. And so that means this has a charge of 2 electrons, negative 2 times 1.6 times 10 minus 19th coulombs, and this has a net charge of 2 protons, or 2 times positive 1.6 times 10 minus 19th, positive. So as we saw in the PowerPoint, charge is conserved. We still have 0 net charge here. Now this is called charging by friction, and what happened is some of the fur's electrons were rubbed onto the rod, leaving the fur with Q equals plus Ne and the rod with Q equals negative Ne. And remember, this little symbol E is what's called one elementary charge. It's the charge on either a proton or electron because they have the same magnitude charge. It's just that the charge is opposite for the electron. N is some integer depending on how many electrons were transferred between these 2 objects. So there's the answer to step number 1. I'll pause the video, let you have an opportunity to jot that down. Okay, let's move on to the next part here. We have in number 2, the teacher brings the charge rod near the neutral pith ball. Record the observation. You should have said the pith ball was attracted to the rod in some way, okay, moved toward it or something, but basically attracted. What happens? So we had to use one of these terms. The term is polarization. And here's a description of what polarization means. The orbits of the electrons in the pith balls were distorted, so the electrons were further from the rod than the protons, resulting in a net attraction. So I've sketched a little simple diagram here. See, I drew 3 simple atoms, and the electrons tend to spend more time on the back side of the atom because they're repelled from this. And so the attraction between the proton and this negative, opposites attract, is greater than the repulsion here because these electrons are further away. And so we have more attraction, less repulsion means net attraction toward this negative here. So I'll pause the video and give you an opportunity to jot that down. Okay, let's move on to the next example here, the next part. Number 3, the teacher touches the rod to the pith ball. So the observation is the pith ball sprang away from the rod and then it remained away. I don't know if you remember that, but it touched and then it jumped and then it was hanging away like this. The explanation, what happened? So this is called charging by contact. The rod transferred some of its electrons to the pith ball through touch. They were both negative. They repelled each other. Since they repelled each other. So that's the explanation. I'll pause the video to give you an opportunity to jot that down. Okay, let's move on to the next step here, step 4. after touching both pith balls, the teacher removes the rubber rod. First thing you do is you sketch two pith balls in this space. So they were hanging apart like this because they repelled each other. Okay, so that's the first thing, the diagram. And then you have to say a description that the two pith balls repelled each other. Okay, and the explaining of why, you could say since they were both the same sign charge, negative, they repelled each other. Okay, so there is the explanation. I'll pause the video, give you an opportunity to jot that down. Okay, let's move on to the final step here with the pith balls. So here it says the teacher then touches both pith balls with his hand, then removes his hand. So the sketch would be to show two pith balls hanging down, and the explanation, the recording of the observation, is the two pith balls hung down in contact with each other. That's just describing what we saw. Now the why. The term that applies here is grounding. And the explanation of that is that the excess electrons on each pith ball were removed by electrically connecting them to the earth. Well, I touched them with my hand, but I was standing on the ground, so I was connected to the earth, and I was the conduit for the electrons to go from the pith ball through me and into the earth. Okay, I'll pause the video, give you a chance to jot that down. Okay? All right, let's move on to the next thing, the questions here. And so the first thing is, number one, okay, so number one says the teacher brings a positive rod next to a pith ball. It attracts the ball. What are the possible charges on the pith ball, and explain? So one thing is the pith ball could be negative, and then you'd have positive negative attraction, or it could be neutral, and then we'd have attraction through polarization. Okay, so that is the answer there. So when two things attract, you don't necessarily know they're oppositely charged, because the object that's one of them is made of atoms, and it could be neutral, and then there's attraction through polarization, or it could be oppositely charged. All right, number two, the teacher brings a positive rod next to a pith ball. The rod repels the ball. What are the possible charges on the pith ball, and explain? The only possibility is that the pith ball is positive. And the reason why is you can only have positive repulsion. You cannot have charge polarization and then repulsion. Charge polarization always results in an attraction. Okay? Next question. If a pith ball has 1,250 more electrons than protons, what is the charge on the pith ball? So we use this simple formula, Q equals NE, where N is the number of electrons that we have, and each electron is negative 1.6 times 10 to minus 19 coulombs. We multiply those out, we get the total charge. And number four, if a pith ball has 850 fewer electrons than protons, so that means it has more protons, what is the charge on the pith ball? Same formula, but now we put in 850 for the extra protons, and the protons are positive instead of negative, but the same magnitude, 1.6 times 10 minus 19th. When you multiply those out, you get this as an answer. I'll pause the video to allow you to catch up with these if you need a moment. Okay, so we'll move on to the electroscope now, part 2. Okay. So in this demonstration, what I did is I charged up a rubber rod with fur, and then I brought it near a neutral electroscope without touching it. And then here it says sketch the vanes as well as the charge distribution. So what you have to do is draw the vanes spread apart like this. And the observation is the vanes spread apart. But also the charges. What happens is this minus up here repels some of the minuses away from, in this plate, some of these atoms are, the electrons are pushed down into the veins, and since this is a metal, they're free to move. Instead of staying here and polarizing the atom, they just go all the way down and move to the bottom from one atom to the next. They're passed along, and now these are both negative, so they repel. But notice I have 4 minuses here. I have to have 4 pluses up here because the electroscope was never touched, so it has to remain overall neutral. And if I had an extra plus here, well, now where did that extra charge come from if nothing touched the electroscope? So key idea there. All right, let's explain what happened. The term is polarization. Some of the electrons in the top plate of the electroscope were repelled to the vanes, right? The vanes then repelled each other because they were both negative. So I'll pause the video there, give you an opportunity to jot that down. Okay, let's move on to step 2. Okay. Step 2, the teacher then removes the charged rod. Sketch the vanes, just draw 2 vanes hanging down like this, and then the vanes hung down because they were no longer repelling. So missed the word there. Here's the explanation. The extra electrons in the vanes traveled up and rejoined the unpartnered protons in the plate above. Since they are neutral again, they no longer repel. So remember here we had these electrons were repelled down by this negative. Once this negative goes away, these electrons rejoin the protons that were left behind by the migration of the electrons. Remember, in a metal, protons don't move unless you melt the metal and make it flow as a liquid. Then the nuclei of the atoms can move too. But for a solid metal, the atoms are they're staying put. So the nucleuses of the atom cannot move, but the electrons can. That's why it's a conductor. Okay, so let's move on. I don't know if I paused, but I'll pause the video here to give you an opportunity to jot this down if you haven't already jotted this down. Okay, let's move on. So here we've got step 3. The teacher brings the rod back to the electroscope, touches the electroscope, then removes the rod. Sketch the vanes on the bottom as well as the charge distribution. So I make the vanes spread apart. And then notice I've got minuses all throughout the electroscope because I touched it with a minus, so it basically charges everywhere up. And the recording of the observation, the vanes stay spread apart. The explanation of what happened, first of all, the term is charging by contact, and then the explanation is the rod transferred a bunch of electrons to the electroscope when it was touched. The vanes are now both negative, so they repel each other, charging by contact. I'll pause the video to give you an opportunity to jot that down. Okay, so let's move on to step 5. Okay. The teacher then touches the electroscope with his hand and then releases it. So the way you draw the vanes is hanging down and no charging because the electroscope is basically going to come neutral. That's what we're going to explain here. The observation is the vanes hang down without repelling. And the term is grounding. The electroscope's excess electrons were removed into the earth, leaving it neutral. As a result, the vanes no longer repel each other. Okay, so I'll pause the video, give you an opportunity to jot that down. And the last one was step 6 here. So the teacher can only charge the metal plate by placing it on a charged plastic plate, then touching the plate with his finger, then removing his finger, then removing the plate. If any step is left out, the plate will not acquire a charge. Okay, so what happens in step 1 is I put the plate on this metal plate on a charged plastic plate, and that makes some of the electrons in some of these atoms down here migrate up to the top of the plate because they're repelled from this minus below. And again, this is a metal. So it doesn't just distort the orbit. The electron's allowed to move from one atom to the next until a bunch of electrons congregate here. But notice I have 6 electrons here and 6 protons because this is still neutral. Okay? Step 2, I touched the top of the plate, the metal plate, with my finger, and notice I drew 6 electrons inside my finger. Those electrons jumped into my finger and they continued on to the rest of my body and into the earth. Okay? And that leaves these protons still there without their electrons because their electrons have now left into the earth. Then I take my finger away, and so these positives are now stuck without their electrons that are gone. And then I lift the plate up, and then I have the plate as positive 6. This is charging by induction, and I explain the 3 steps here. Okay, so jot these down, and I'll pause the video to give you an opportunity to do that. Okay, so that is, or those are the answers to this lab that I did, or this set of demonstrations where I was charging various things up and illustrating the charge effects. All right, so there you have it, the answers, and I will see you in the next physics video.